Saxon Algebra 1/2, lesson 93. Today we're going to talk about fraction bars, but before I divulge to you the secrets of that lovely topic, look, it's the last week before the midterm, before spring break. So, counting down. Okay, order of operations. First, we deal with anything in parentheses or brackets of any kind. Then we deal with powers and roots. Then this x represents a number, but then we use that x to signify multiplication and division are the third step. Addition and subtraction come last. That's our order of operations. We've been talking about this for quite some time, haven't we? What we haven't done a lot of talking about is division. Division in order of operation problems. We've kind of not had many examples of that, and today we're going to discover why that is. Now, we can have division in an order of operations problem. It would normally, if we were going to write it so it looked familiar, it might look like this. Okay, there's an example of an order of operations problem that includes division. So, what would we do? First, we'd work inside the parentheses and look for things to do there. Okay, there's a multiplication. Now, in here, there's two. We'll do the multiplication first, and then we'll do the addition. Okay, so let's do those projects. This one becomes 20 divided by, and we multiply first, that's 8. 8 plus 2 is 10. Oh, 20 divided by 10 equals 2. Okay, great. But that's not the way we normally, we meaning mathematicians, normally format problems that have division in them. We would do it instead. This is option A. This is the way mathematicians would prefer to set this problem up. Okay, there's what we had in the first one, but look, instead of using parentheses, we make a fraction bar. The reason that this works is because the fraction bar always says, and you're going to hear me say this a trillion times, it says divided by. The bar talks. I know. Did you have any idea? Fraction bars always mean divided by. I think I've told you that before, now that I think about it. When we go to simplify a fraction and to turn it into a, excuse me, that was a much needed yawn. When we turn a fraction into a decimal, we remember that that bar says divided by. Well, we use the same rule here. And so the way we would do that, again, is we would simplify the top and then the bottom, and finally divide. Okay? That doesn't necessarily look like it's following these rules, but that's how we do it. Always, always, always. Okay? So here we go. Here's the first example. 93.1. There are two examples. I mean, what we've already done is kind of like one. Oops, that's a 2. Now I'm going to write this in a weird way. Okay, if you will see in the book, this just looks like normal. Why have I spaced it out in such a weird way? I will tell you why. It's because I know I need to simplify the numerator and simplify the denominator. And this is a trick I use so that when we're done, our answer will be written above and below the line and we won't have to recopy it so that people can see it. So I like to use this strategy. I put the line in the middle and I give myself, I'm going to work down and I'm going to work up, and then my answer will end up right in the middle. Okay, so let's simplify what's in the parentheses. All right, this I can do, right? This will become 4 minus 4 plus 3 times 2 plus 6. Okay, then this I can simplify as 2 times minus 5, right? Minus 4 minus 1. Okay, so now I've simplified what's in the parentheses. Now we will do multiplication and division, but not this division. That comes last, just by following the simple rules. This I can simplify just because that's 4 minus 4. That's going to be 4 plus 4, right? Plus, and then here's a multiplication. 3 times 2 is 6 plus 6. Aha! So 4 plus 4 plus 6 is 20. And then 2 times minus 5 is minus 10. So I can write my final answer over here. It's negative 2. See how this just, by working down and up, it just helps me get my answer gathered together so I don't have to rewrite it. I hate the rewriting. Okay, and one more. I'm going to go to the next page so I have a little more room. Don't want to squeeze it and make it a giant mess, and you'll be like, what is she even doing? I mean, you might be doing that anyway, but I don't want to give you extra reasons to do that. Okay, there's our original problem. Order of operations, we do parentheses and exponents first. So I can clean this up, and I can clean that up, and I can clean that up. Okay? 6 times, this will be minus 1. Minus, and then that will be minus 8, right? I'm adding with this one as well. And then this, there's no work to do inside those parentheses. That just means multiply. This I can fix, though. 3 times minus 2. Okay? Now we have multiplication. That's a multiplication. That's a multiplication. And that's a multiplication. All right. Minus 6 minus, that's this minus. Then this becomes minus 16. And this is just minus 6. I'm going to write that all the way up there because that's the final answer on the bottom, the denominator. All right, minus 6 minus a minus 6, that becomes minus 6 plus 16, which equals 10. 10 over minus 6, we can reduce that. It's going to be minus, I'm going to divide top and bottom by 2, minus 5 over 3. Okay? There is our final answer. So that's how you do it. You just use this division bar as the final step, and I know that probably seems confusing, but that's just the way mathematicians have agreed to use these division bars. They are the last step, right? We simplify the numerator, we simplify the denominator, we meet in the middle, and then we simplify. Yay! 93 is done! Goodbye, my students!